Hello, my amazing students. This is Mrs. A, and I love math. Today we're doing lesson 55 in your Saxon Orange Book, and we're talking about complex fractions. Well, what is a complex fraction? It is a fraction within a fraction. If we are dividing two quantities, that's a fraction. But if we have a fraction in either the top or the bottom of a fraction, so a fraction within a fraction, then that's called a complex fraction. So here we have an example where b cannot be 0, c cannot be 0, and d cannot be 0. Well, we can see right away why b cannot be 0 and why d cannot be 0, because they're denominators of the individual fractions. However, the way we are going to work this is by using this rule. Division is equal to multiplication by the reciprocal of the divisor. So the divisor is going to flip over. Then this one will be the denominator. So this is only defined if B, C, and D are all not equal to 0. Okay, this is our first example. We have a fraction divided by a whole number. Well, we're going to have to change the division into multiplication by the reciprocal. So to make that easier, we're just going to express the whole number c over 1, because we can put any number over 1. Any whole number over 1 is still the same value. So we're going to change the denominator to a fraction instead of a whole number c. So now we're going to apply our rule. Division is the same as multiplication by the reciprocal of the divisor. So we're going to get a over b times, and then we flip the denominator's fraction over, and we get 1 over c equals a over bc. And that is true. Okay, now some of you may wonder why this is so. So let's go back to just the generic c over d. And I want to explain to you why this is always true. Because a lot of students just think, well, I flip the denominator and then I multiply, but they don't know why they flip the denominator and multiply. So I'm going to show you why this always works. A over b divided by c over d. Now, let's just play with it for a minute. Let's pretend we don't know how to do it. And so we're going to start by trying to get rid of that pesky denominator. So we're going to multiply by d over c. But if we multiply the denominator by d over c, we must multiply the numerator by d over c. Well, we know that this cancels out, doesn't it? And so now, what do we have? A over b times d over c is equivalent to what we started with. Because what do? We multiplied by 1 in the form of the reciprocal of the denominator to get rid of the denominator. So now let's go back to what we started with. We started with a over b divided by c over d, and we wound up finding out it was exactly the same as a over b times d over c, which is the reciprocal of the denominator we started out with. And it always, always, always works. Okay, so we know that c and b cannot be 0. So we're going to go ahead and use our rule. Division by a fraction is multiplication by that fraction's reciprocal. So 1 over c times, we flip this one over, b over 1 is b over c. And it's as simple as that. Here's the next example. Now, in your book, they make this line a little bit darker. The big division symbol, they make it a little bit darker. I'm making it a little bit longer, so it's no confusion as to where the big division sign is. So a divided by 1 over c is the same thing as a times c over 1. Well, we can put a over 1 too if we want to, and the answer is a times c, or ac. This one looks much more complicated, but it's really no different. We're going to turn this one over and multiply. So we're going to say this is equal to a over x times, we flip this one over, a plus x over b. So now we have a times a plus x over xb. And that is our answer. Okay, so we're on 55b now, division rule for complex fractions. So we've already talked about this, but we're going to go over it one more time. The rule for dividing fractions is to flip the denominator up and multiply. So we're going to flip this over, y over x, and then we multiply my over nx. Now we're going to do the same thing. So this one was x over y. Okay, so let's go back to the original. I'm going to leave the answer there so we remember what it was. And instead of using the flip the denominator up and multiply, we're going to, and some people like to call that the keep, change, flip. Okay, so basically they're keeping this one and they're flipping this one. But I just say division is multiplication by the reciprocal. That's how I say it. But let's use the denominator numerator same quantity rule, which says that I'm going to multiply this one by y over x to get rid of this denominator, which means I must multiply the numerator with y over x. Now this quantity here, since it's the same in the numerator and the denominator, is 1. Okay, so we're multiplying by 1, which changes nothing. But notice that this is now gone, and we are left with the same multiplication problem we had the first time, my over nx. Okay, so then they go into just talking about these 3 rules that we're going to use over and over and over again to justify our actions when we're trying to solve equations. The denominator numerator same quantity rule, which is what I just showed you. The multiplicative property of equality, which says that I can multiply both sides of an equation by the same non-zero quantity. And the additive property of equality, which says I can add or subtract the same thing to both sides of the equation. And of course, the multiplicative is I can multiply or divide both sides of the equation by the same non-zero quantity. So those are 3 major rules that we're going to see over and over and over again in our dealings with equations. Okay, so here I have a fraction divided by a whole number. In order to be able to do this one easily, let's just stick a 1 under there. So now I have an easier reciprocal to get. So the reciprocal will be 1 over d. So I'm going to multiply by 1 over d, and that's the same thing as dividing by d, because we could do it using the what? Numerator, denominator, same quantity rule, just like we did before. Or we can say division by a fraction is multiplication by its reciprocal, which is what I'm using. And we end up getting x over md. Now, I shouldn't have done that for you because that was one of your practice problems, and I did the whole thing for you. I'm sorry. Okay, so just so that you will believe that it always works, I'm going to do this one 2 ways. I'm going to show you using division is multiplication by the reciprocal. So we will take the reciprocal, flip it up, change it to multiplication, cross that out, and we get z over r. Or we can do the same thing by, this was 1 over z, so we'll put it back again. Now we're going to multiply by the reciprocal on both the top and the bottom. So that's going to be z over 1, z over 1. This cancels because it's 1, and we get z over r again. I just did another problem for you. This time I'm not going to forget. I want you to copy it down and pause your video and go do it yourself, and then come back and check and see if you got it right. All right. Hopefully you did that. So now we're going to multiply by the reciprocal, which is D over B. Cross that out because it's been replaced. And ND over AB. Did you get it right? Okay, so here we're going to multiply by the reciprocal. So we'll have times W plus C over 1. This is going to cancel. And we have W times W plus C. That's our answer. And that was our last practice problem. And this is Mrs. A, and may God bless your day.